Hi everyone. We're going to start with Unit 3 today, factoring polynomials. Today we're going to start with the very first step to any factoring problem, which is factoring out the greatest common factor, or the GCF. Every single problem that we do in factoring, that's the very first step. We're going to have to check for a greatest common factor. Greatest common factors could be numbers, or it could be variables. Or both. So let's see what I mean by showing you a few examples. Okay, so we're asked to factor out the GCF. Sometimes your directions might just say factor or factor completely. All right, the very first thing that you should do though is always check for a greatest common factor. A nice way for us to do that is to find the factors of the numbers that are out in front. So we're going to take the coefficients of the terms that are here, which in this case we have 20 and we have 32. And what I'm going to do is I'm going to list all of the factors like we did when we had to find just the GCF, when that was just our directions. So for 20, you have 1 times 20. You could use your calculator for this too. You could take 20 and divide it by 2. You would get 10. 2 times 10. 20 divided by 3 gives you a decimal. 20 divided by 4 gives you 5. So 4 times 5 are a factor set of 20. The number that comes after 4 is 5, and we already have it listed. So I'm done with my factors of 20. There they are. You're going to do the same thing for 32. You have 1 times 32. Then you're going to try dividing it by 2, and you get 16. Then by 3 will give you a decimal. 4 gives you 8, so 4 times 8. 5 doesn't work. 6 will give you a decimal, so will 7. 8 is the next number, but we already have 8 listed, so therefore they're my factors of 32. Now, I have to find the number that both of them, the biggest number, the greatest number that both 20 and 32 have in common. So I look under 20, because you always start with a smaller number, and you see if 32 has the number. So you go backwards. You go from 20 and a backwards U. So you start with 20. There is no 20 here. You have a 10. You don't have a 10. A 5. No 5. I have a 4 here. And I have a 4 here. So my GCF for 20 and 32 is 4. Okay, that's the biggest number that'll go into both 20 and 32 evenly. And then you'll notice that both terms have a W. This one's W to the 10 and this one's W to the 8. Recall that when we were doing greatest common factors, you're always taking like variables, or variables that each term has in common. So you will take the W and you're going to take it to the smallest exponent. So the smallest exponent that you have here is 8. 8 is smaller than 10. Now that we've identified our greatest common factor, we're able to factor it out or divide it out. So I'm going to take my GCF. GCF becomes the number that you rate the most. So you take your greatest common factor and you divide both or each term by the GCF. And after I write it underneath, I'm also going to write it outside of a set of parentheses. Inside here is the quotient from this, or is what I get after I divide both terms by 4W to the 8. So let's see. 20 divided by 4 is 5. Keep your W. And 10, or W to the 10 divided by W to the 8. If you recall our laws of exponents, when you're dividing with the same base, you keep the base and subtract the exponents. So 10 minus 8 gives you 2. okay, plus you have 32 divided by 4, which gives you 8. But here you have w to the 8th power over w to the 8th power. And anything over itself cancels because it gives you 1. So you could cancel out the w to the 8ths. And now you have this. This is your answer. If you wanted to check this answer, you could distribute. And when you distribute, you are going to come up with the question. And that's factoring out a GCF. Let's look at the next one. So we're finding the GCF. Here's something that we didn't hit in the first problem. If the leading term or the leading coefficient is negative, your GCF is negative. So before I even find what 4 and 2 have in common, I'm going to take a negative. Okay. So now I'm going to put the factors of 4 and the factors of 2. This task is a little bit easier. So the factors of 4 and 2, they have 1 in itself. For 4, 4 has 2 and 2. We're done with 2 though. And you're looking for the number that they both have in common, the biggest number, and that would be 2. Okay. Now, again, you're taking a variable. They both have the same variable, x. And you're taking it to the smallest exponent, which is 3. All right. So you take this negative 2x to the third and you start dividing. Okay. So negative 2x to the 3. And you're dividing. Negative 4 divided by negative 2 is positive 2. x7 divided by x3. Keep your x, subtract your exponent. 7 minus 3 is 4. Next, you have negative 2 divided by negative 2. That gives you a positive 1. And again, anything over itself, this x3 over x3, they cancel out. And that's all you're left with. And that is your answer. Let's look at 2 more examples. They're a little bit harder. All right, we have 18 and 27. So 18 and 27. It's going to list our factors, 1 and 18, 2 and 9, 3 and 6. And for 27, we have 1 and 27, 3 and 9. And that's it. So the biggest number that they both have in common is 9. So our GCF is 9. Then we're going to look at the variables. They both have an x. You're keeping the smaller one, so you're keeping x3. They both have a y. The smaller one is just y, or y to the first power. Once you've identified your GCF, that's what you divide by. And then you write that on the outside of your parenthesis. On the inside is the quotient. So 18 divided by 9 gives you 2. x3 over x3, the same number over the same number. Remember, we cancel them. Okay, because they match. And guess what? So do the y's, because it's the same thing. Anything over itself cancels. You have negative 27 divided by 9, which is negative 3. And then you have x8 over x3. 8 minus 3 is 5. And be careful here. You might want to add a 1 so you don't forget to subtract 4 minus 1. So you keep your y, but you have 4 minus 1, which will give you 3. And that is your answer. Finally, this last one. This last one's a little different. Again, if your leading coefficient is negative, your GCF is negative. Here we have 1, 2, 3 terms instead of just 2. We have a 6, a 2, and a 14. Okay, so the factors of 6, 1 and 6, 2 and 3. Factors of 2 are just 1 and 2. And 14 and 1 times 14 and 2 times 7. Now, the biggest number that all three of these numbers have in common is 2. Now we have to look for variables. The first term has a variable, it's x. The second term also has an x. But the last term does not, so you cannot factor out an x. All three have to have it. So it turns out that our GCF is just negative 2. So you write your negative 2 outside of a parenthesis. Inside of it, you're going to put the quotient. So negative 6 divided by negative 2 is positive 3. 2 divided by negative 2 is negative 1, or just negative x to the 6. And positive 14 divided by negative 2 is negative 7. And that is how we factor out a greatest common factor. Again, you always have to look for a GCF in every single problem that you do when you're factoring. So this is always going to be our first step. I'm always going to ask you if you have a greatest common factor. All right, we'll see you in the next one.